Hi, this is Mr. Royks, and we're going to talk today about properties of matter in this podcast. Some of this will be review and some of it will be new information, so take notes as you feel necessary. So if we're talking about properties of matter, we're first going to describe physical properties. And physical properties could be described as observable without changing the substance. So things that you can record using your senses would be considered physical properties. Color would be an example of physical property. Density. Odor. Melting point. Boiling point. Mass. Volume. So all these are examples of physical properties. They are not the only physical properties, but they are certainly physical properties that you should know and you should be familiar with in this class. As we look at these physical properties, the physical properties break down into two categories: intrinsic or intensive properties, which are not dependent on sample size, and extrinsic or extensive properties that are dependent on sample size. So we're going to look at these two categories of physical properties: intrinsic and extrinsic, or intensive and intensive, and take some of those previous physical properties and categorize them. So examples of intrinsic properties or intensive properties would be density, boiling point, melting point. Again, the example I believe I gave in class was if we have a small beaker full of water versus a bathtub full of water, and we wanted to determine what temperature would the water boil at, it doesn't matter if we're talking about the small beaker or the large bathtub. All water boils at 100 degrees Celsius in standard conditions. So that's an example of an intensive property. Same thing with density. Density of water is 1 gram per milliliter, so it doesn't matter whether we have a large sample of water or a small sample of water, it is going to have the same density. Extrinsic properties, on the other hand, or extensive properties, are dependent on sample size. So if we had, obviously again, small beaker of water versus a large bathtub full of water, we're obviously going to have differences in mass and volume. So that's the difference between those, and that's what you should be familiar with for this class. Now we'll get into chemical properties. Chemical properties could be defined as, or describes how matter changes into other substances. So with physical properties, the matter is going to remain the same. The composition of the matter will remain the same. So those are all things we test without changing the composition of matter. Whereas chemical properties, we now have to actually change the matter in order to determine those chemical properties. So they're observable only through that change in matter. An example of a chemical property would be flammability, reactivity, acidity. And again, these are just a few samples of chemical properties, certainly not covering all chemical properties of matter. Now let's talk about what are we dealing with a physical change versus a chemical change. So how can we define changes in matter? So a physical change is a change in appearance only. The composition remains. So for example, if we take a rock and we hit it with a hammer and break it into pieces, that would be a physical change. It's still going to be whatever the composition of the rock was initially. It's now in pieces, it's been cleaved, but in general, it's still going to have those same properties. The intensive properties are still going to remain the same. Versus now a chemical change. A chemical change would be a change in composition. Okay, an example of a chemical change would be burning methane. So when we use the Bunsen burners in class, the CH4 reacted with oxygen to form carbon dioxide in water. Okay, and that would be an example of a chemical change. When we're talking about changes between states of matter, it's important to realize that changes between states of matter are physical changes. Yes, the appearance does change, but the composition itself doesn't change. So, for example, if we take water and we freeze it into ice, water into ice is still going to be water. It's still going to be H2O, 2 hydrogens and 1 oxygen. It doesn't matter that it is now a solid versus a liquid. It's a physical change. Same thing if we were to boil water and cause liquid water to change to gas. Again, we're not going to get a change in the composition. It's still H2O. It looks different, but it is still that same composition, so that would make it a physical change. All right, so I want you to kind of think about, I'm going to post a worksheet that will kind of make you think a little bit more about these physical change versus chemical change, physical properties versus chemical properties. And if you have questions on these, certainly ask in class. All right, we'll see you soon.